in this experiment, we'll be demonstrating Gay-Lussac's law with the correlation between temperature and pressure. Now, temperature and pressure are directly proportional to one another, with P1 over T1 equals P2 over V2. Now, remember your lab safety Ags. You're going to want to have some closed-toed shoes on, long pants. You don't really need a hazmat suit. I just did this for video purposes. You're going to have some goggles on, as well as a face mask. Now, females or men with long hair, you're going to have to tie your hair back because we're going to be dealing with flames and you do not want to catch that on fire. Remember to be safe. Now, the materials you'll need to replicate this experiment is a closed system, food coloring, matches or a lighter, candles, and something to hold your water in. Now, the first step to this experiment will be putting your food coloring in the water. So I'm going to choose red here. The second step to this experiment will be placing your candles gently in there so the water does not touch the top of them. I'm going to use 3, but you can use as many as you want. That'll fit in your closed container. And now you're going to want to light your candles. And be sure to put the closed system on the candles right after all 3 of them are lit. Now put the closed system on top of the candles, gently.
After the candles go out, we can see the water rise. The purpose of the food coloring is to be able to see this more clearly. Again, under constant volume and mass, temperature and pressure will be directly proportional to one another.
Now in this experiment, when you light the flame, the temperature obviously increases. The O2 molecules, because of this, tend to get excited and they push against the sides of the closed system. Now the reason the candles go out is because as the flame is lit, CO2 molecules as well as vapor pressure are released. Now this pushes the O2 molecules down, causing the flame to cut. Now after the flame is burnt out, the O2 molecules want to return to their original state. The air pressure under the beaker needs to be equal to the pressure on the outside, or wants to be. Therefore, instead of pushing against the sides of the closed system, it now pulls, causing the water to rise. Now, in conclusion, by Gay-Lussac's law, which is P1 over T1 equals P2 divided by T2, pressure and temperature are directly proportional to one another. Now, this is highlighted by increasing the pressure under the cup or your closed system.